I had a request that someone wanted me to find the inverse Laplace transformation of this function. So in order for us to find the inverse Laplace transformation, the first step is to find the poles of our function. And just by looking at these, we can see our poles are real numbers. And to find the poles, we have to set our denominator equal to 0. We got to set that equal to 0, so our poles will be 2 and -1 and 3. So our Laplace transformation, Fs, it can be written as 2s squared minus 4 divided by s minus 2 times s plus 1 times s minus 3, which can be written in a form of our constant associated with our first pole divided by s minus 2 plus our constant associated with second pole divided by s plus 1 plus our constant associated with our third pole divided by s minus 3. So our main function will be equal to our constant associated with pole 1 multiplied by e to power 2t plus cp2 multiplied e to power minus t plus cp3 multiplied by e to power 3t. So now let's use our algebra skills and find the values for cp1, cp2, and cp3. So let's go ahead and multiply both sides of this equation by this term, by that term. So on the left side, we are going to have 2s squared minus 4 will be equal to cp1 multiply s minus 2 will cancel out, so we are going to multiply by s plus 1 times s minus 3 plus cp2 multiplied by s minus 2 times s minus 3 plus cp3 multiplied by s minus 2 times s plus 1. Now let's go ahead and apply our poles. So if s equal to 2, then we are going to have 2 times 2 squared, 2 squared which is 4, 2 times 4 is 8, minus 4 will be 4, is equal to, if s is equal to 2, so that term will be 0, and this term will be 0. So 4 is equal to cp1 multiplied by 2 plus 1 is 3 times 2 minus 3 times minus 1. So our cp1 will be equal to minus 4 divided by 3. And now if we set s equal to minus 1, so will be minus 1 squared is plus 1, so 1 squared will be 2 minus 4, we are going to have minus 2 is equal to, s equal to minus 1, that means this term will be 0, and that term will be 0, so we are going to have equal to c CP2 minus 1 and minus 2 will be minus 3, and minus 1 and minus 3 will be minus 4. So minus 3 times minus 4 will be 12. So from here, our CP2 will be equal to minus 2 divided by 12, which is minus 1 over 6. And if we said S equal to 3, so this term will be 0, and that term will be 0. So we are going to have CP3 times 3 minus 2, which is 1, and multiplied by 3 plus 1, which is 4. So we are going to have on this side 3 squared will be 9, 2 times 9 will be 18, 18 minus 4 will be 14, is equal to 4 CP3, 4 CP3. So from here, our constant associated with third pole will be equal to 14 divided by 4, which is equal to 7 divided by 2. So now we have the values for CP1, CP2, and CP3. We can plug that in this equation. So our function will be CP1, which is minus 4 over 3 e to power 2t, plus CP2, which is minus 1 over 6, minus 1 over 6 e to power minus 3, plus 7 over 2 e to power 3t. So this will be our original function. So the inverse Laplace transformation of that function will be equal to that. I will solve another problem like this, which another guy have sent a request, and then after that we will look at some very good problems in differential equation.